Good evening. My name is Eric Baxter. I'm a firefighter, lieutenant, Statesboro Fire Department. Today we're going to briefly talk about the different types of fires, similarity differences in premix and diffusion flames, combustion, so on and so forth. We're going to start off with the 5 different fires classifications: A, B, C, D, and K. Class A fires is your everyday burning material around your house: cloth, plastics, wood, rubber, so on and so forth. That can be extinguished with simple water, garden hose, so on and so forth. Dry chem extinguishers, if you be Class B fires, is you're burning liquids and gases. You got to be a little more aware of what you're doing there. The best way to do that is cool the area, vapor suppression, smother it if you can. You're trying to separate what is going on there. Don't let the fuels get to their LELs or their UELs, because it's going to be a bad day for everybody. That's more of a hazmat situation at that point, depending on the call, depending on your department's SOPs and SOGs, so on. Your Class C fires are electrical fires. Most of these fires and suppression systems are set up in big data saver rooms. Again, that we don't put water on electrical fires, neither should you. That's a big mess. It's going to hurt you as well. The best thing to do is unplug it, call 911, so on and so forth. Your Class D fires is combustible metals, magnesiums, titaniums, zirconium. The list goes on. Those are very reactive, very colorful when you do add water. Best thing to do is just dry sand, any type of dirt, dry chemical extinguishers. Dry powder extinguishers. Those will be effective for Class D fires. Your Class K fires, last but not least, kitchen fires. We all seen them in commercial kitchens. They have their own suppression system. That's all handled and taken care of by their own suppression team. I say team, it's a company that comes in and handles all that. When you're at home, don't throw water on grease fires. 9 times out of 10, that's what starts it. You put water on grease, it's just going to spread rapidly. You get burned. Cut your stove off if you can. Put a lid on it. Cut your stove off. Cut the grill off. Whatever you're doing, don't throw water on it. There are other methods that I have seen work. People say flour. Flour is a good one. Don't put sugar on it. Sugar will take off as well. We're going to move into your different flame types, your premixed and your diffusion flame. Your premixed flame is formed under a certain condition during the combustion of the change before fuel and an oxidizer. And your diffusion flame is a flame which an oxidizer and a fuel are separated before burning and before combustion. Those are the two differences between the two types of flames of your premix and diffusion. We're going to move into heat of combustion and combustion efficiency. Heat combustion is more of your heat energy involved in the complete combustion part of the process, specific amount of substance, which means is the heat amount of energy that gets replaced throughout this area. I say replaced, it's reduced as the fuel and the heat, as the fuel and the oxidizer throughout the area is gone. It heats up. We're looking at the energy is whatever's in your room, as in sofas. More of your synthetic materials are going to burn hotter, they're going to burn faster. What's that mean? Bigger flames, fire spread, heat release rates, all that goes up. When that goes up, what does that mean? Our heat combustion. Our combustion efficiency, what that means is it can't reach 100% in a fire. This is due to the loss of the heat, the loss of the oxygen levels in the chemical reaction. Things are on the downside. Things are coming back out of this. So good for us, but that's the difference between the two. Your fire tetrahedron, fire triangle, combustion triangle, there's a lot of different names for it. You got your fire, you got your oxidizer, fuel, and heat. They all play a part. Without one, you ain't going to have the other, no matter which one you take out. Then you got when all 3 of them are in line, you have your chemical chain reaction. That's how it works. Again, without a missing link, it's going to struggle. You got to have all three of them to get your, oh, my phone's falling. You got to have all three of them to get the chemical chain reaction. Talk about smoke, smoke plumes, the way smoke moves. What's that mean about the flame? You can tell a lot about a fire by the color of the smoke, the way the smoke is moving. Is it pushing the color of it, so on and so forth. The flame plume indicates the combustion area, dark smoke, yellow smoke. Is it traveling? Lazy smoke. Lazy smoke tells you it's a slow moving fire, the fire's out. Whitish smoke is more of your wood burning, paper. Black smoke is, black turbulent smoke is, you got a good working fire. You got a lot of combustible. You got a good fire load. And if it's breathing, it's puffing at you, there's some indications there we need to look for: backdrafts, flashovers, rollovers, so on and so forth. Most of you know this. Those of you that don't, you should look into it. Another thing we need to look for, though, is smoke in general. Smoke in general is unburned gases, carcinogens. One is bad for our lungs, is very hot layers of gas that are unburned. It's bad for our lungs, it's bad for you in general. We breathe it in, or we become part of the problem. We're there to help the problem, not make the problem worse. That's all I got for you. Thank you.